SpaceX just completed its 11th Starship test flight, and it marked the end of an incredible era for the program. This final mission of the current design was nearly flawless, giving everyone a spectacular show and setting the stage for the exciting upgrades coming next. Let's dive into what made this launch so special. The mission used a super heavy booster that had already flown before, originally launching back in March on the 8th test flight. After its previous mission, it was taken back to the Star Factory for cleaning, inspection, and some minor refurbishment. While a few of the Raptor engines were replaced, 24 of the original engines from the earlier flight returned to duty for this launch, and they performed perfectly. The liftoff was a stunning sight, with the rocket climbing smoothly into a clear evening sky. The booster executed its separation maneuver as planned and then began its return journey back toward the ocean. For this landing, the team tried a new engine sequence. Instead of beginning the landing burn with 13 engines and then switching to 3, they tested a revised approach, starting with 13, then dropping to 5, and finally using only 3 engines right at the very end. This new procedure is a practice run for the upcoming booster design, as it helps save a small amount of fuel during landing, which in turn allows more fuel to be used for the ascent phase. While the booster was descending, the Starship vehicle continued its journey through space on a suborbital path around the planet. The main goal was simply to keep the vehicle stable and under control without any failures. Not only did the ship remain perfectly stable during its coasting phase, but it also showcased an impressive demonstration of its aerodynamic control surfaces. These wing flaps performed their job without any damage, allowing for precise maneuvering. About 58 minutes into the flight, at an altitude of roughly 50 kilometers, the vehicle executed its first planned banking maneuver. This was a test to change the ship's direction during flight. Instead of following a simple, straight arc down toward the ocean, the vehicle steered itself in a wide, curving path. This kind of controlled turning is essential for future missions, when the vehicle will need to navigate back to its launch site for a landing. It has to adjust its course from over Mexican airspace all the way to the landing facility in Texas. Then, just before touching down, the vehicle must perform one last rotation to line up with the launch tower and its catching arms. In this test, viewers could see the ship practice that final turn about 65 minutes after launch. It spun around nearly 180 degrees before flipping upright and igniting its engines for the landing sequence. Despite all the complex steering and direction changes, the vehicle managed to land right on target next to a camera buoy floating in the water. It settled gently on the surface before eventually tipping over and breaking apart. This type of landing will not be seen again, as the next flight will introduce a fully new design. Flight 12 begins a brand new chapter. Everything will be different next time, from the Starship itself to the booster and even the launch infrastructure. The new version of the Super Heavy booster will have a completely updated appearance and deliver significantly more power. It will still use 33 engines, but these will be the more advanced Raptor 3 model. These new engines produce greater thrust, increasing from 230 tons to 280 tons each. More importantly, the Raptor 3 features a much cleaner and simpler design. Nearly all the external hoses and wiring have been moved inside the engine casing. This makes the engines easier to manufacture and should improve their reliability during flight, since there are fewer exposed parts that could be damaged during launch or re-entry. The testing phase for Raptor 3 is now finished, and the first flight-ready engines are already being produced. The new booster will also be slightly longer to house larger fuel tanks, which are needed to supply the more powerful engines. A massive transfer tube will run from the top of the booster down to the engines, allowing liquid methane to flow freely. To give a sense of scale, this new transfer tube alone is about the same size as an entire Falcon 9 booster. It's essentially a rocket inside a rocket. At the top of the new Super Heavy, some interesting changes are visible. The most obvious difference is the reduction in grid fins, from 4 down to 3. These 3 fins have been repositioned into a T-shaped layout. The main reason for this redesign was to integrate the catch mechanism for the tower arms directly into the structure of the fins themselves. To make this work, each grid fin has been strengthened and enlarged by about 50%. They are now much bigger and more robust, which gave the engineering team enough confidence to remove one fin entirely. Removing components is a favorite design strategy, so it will be interesting to see if the 3-fin configuration performs as expected or if a 4th fin might be added back in the future. Above the grid fins is another new feature, an integrated connection system for hot staging. Since the second test flight, SpaceX has used hot staging to separate the ship from the booster. This method has worked very well, but it required a heavy interstage adapter to shield the booster's fuel tank from the engine exhaust and to vent gases safely to the side. That adapter may have seemed like a small part, but it weighed around 10 metric tons and was discarded into the ocean after each separation. That is not a sustainable approach for the long term. The new booster solves this by using a triangular arrangement of support beams at the top. This open structure allows exhaust to vent more freely. In the center, a newly reinforced dome section has been added. This dome is actually the top of the methane fuel tank, and extra layers of steel have been welded on in key areas to protect it from the extreme heat and pressure during hot staging. Moving up to the Starship itself, the new V3 model will look quite similar to the current design from the outside, but inside it is receiving many important upgrades. The current version of the ship has been known to have some reliability challenges. Many of the earlier test vehicles experienced unexpected failures, and each of those incidents helped identify a different weakness in the design. Over the past year, the engineering team has been focused on finding problems, fixing them, and then repeating the process with each new test. The 10th flight was mostly successful, but an explosion in the engine bay damaged 2 of the rear control flaps just before re-entry. Learning from these experiences, the team has completely redesigned the fuel delivery system for Starship V3. This new vehicle will also use the upgraded Raptor engine, which should be far more dependable. With all these improvements combined, the new Starship and Super Heavy system will be capable of delivering between 100 and 150 tons of payload to low Earth orbit. That puts its lifting capacity on par with the legendary Saturn V rocket from the Apollo Moon program. But unlike the Saturn V, Starship is designed to be fully reusable, something that was once thought impossible. To support that reusability, SpaceX has provided a detailed look at how orbital docking and fuel transfer will work. The V3 ship will be equipped with new docking ports on the side opposite the heat shield. It appears there will be 2 types of Starship, one designed with a male adapter and one with a female adapter, or one configured for sending fuel and the other for receiving it. Once docked, the 2 ships will transfer liquid fuel between them. This will allow the receiving vehicle to continue on to higher orbits or more distant destinations. SpaceX has stated that this V3 design is not the final version, but it will be the one used for the first attempted landings on the Moon and Mars. We will have to wait and see how those missions unfold. Supporting all of this new hardware will be an upgraded launch pad and catch tower, often called Stage 0. The 11th flight was the last launch from the original tower, and it was the final use of the unique invert. The new tower will feature a more traditional flame trench and water deluge system at its base, similar to what is used for the Falcon 9. The new tower structure will be taller and stronger than before, but the catching arms will actually be shorter. The reason is straightforward. Smaller arms can move more quickly and are more stable. When the first set of arms was built, the team had no prior experience catching a rocket. They did not know how much surface area would be needed, and it turned out that less was sufficient. Now they are applying those lessons to build a smarter, more efficient system. All of these developments give us plenty to look forward to. It means the next phase of Starship will bring even more innovation and excitement. If you enjoyed this update, make sure to subscribe to the channel, like this video, and share it with others who love space exploration. Your support helps bring more content like this to the community.